Let me share the screen, then you will be able to see this. I hope that it is visible to all of you right now. That is the analysis of the embodied
Yes, sir.
energy.
Yes, sir.
Okay, thank you. So this is the analysis of the embodied energy, which is the matter of our concern for today. First of all, we will start with the thing, the meaning of the embodied. Okay. See, embodied means something which is been inside this body. Okay. Which is coming from the inside. Okay. There is some issue with this PPT right now. I'm facing that. That is why I cannot show you the exact thing. Yes, here it is. Okay. So there is obviously when you people are reading something, you must understand that there is a history behind that particular thing, which the researchers have done their work, and after the years of the research, people have come up with some solution which is actually helping we people. Okay, so it is saying that in the year, let me see this, stop sharing. Okay, I'll start presenting again. Here it is. So in the year 1978, just 10 years before, that means in the year 1988, some other works were also done. But in the year 1978, scientist James Hansen warned about the severity of the climate change. Okay, so it is around 40 years ago when we were actually having this thing as a matter of concern, that is, the climate change is about to occur. And I don't know from which part of the country you belong to, but for last 2 to 3 days, I believe most of the people have experienced the change in the temperature drastically in this particular month of January. It wasn't this, I mean, warmer before. Okay, so in the month of January, just on the 8th of January, we are having an average temperature of 24 to 25 degrees Celsius, which wasn't actually expected. And all these things are mainly happening due to the climate change issues. So in the year 1988, obviously, James Hansen warned us about the climate change issues. Another researcher, who is actually an architect by his profession, Richard Stein, co-published a paper. Co-published means he was the co-author. Along with him, some other people were there who were actually involved in that particular study about the energy consumption in the architecture. Obviously, energy consumption in the buildings. Okay, or in case of the bridges, it is also true. So actually, it states that there are some part of the energy which is actually the operational energy. Operational energy means the energy that is actually doing some work to provide us the services. Say, for example, your electricity, okay, that is lighting, obviously, which is written over here. Then heating or cooling. Cooling means obviously the uses of air conditioners are there. Okay, so some amount of energy, which that amount is actually 10%, is actually your embodied energy, which is required to extract, manufacture, transport, and assemble a building's constituent materials. Now, as a civil engineer, you people understand what are the building's constituent materials. Okay, it could be your concrete, it could be your bricks, it could be the woods, anything. Okay, so they have that particular 10% of the energy that is being consumed or that is used by that particular building when it is actually operating. So embodied energy is the total energy required for the extraction, processing, manufacture and delivery of the building materials to the building site. Okay, so this is the way we can actually calculate the amount of the embodied energy. It is the energy required for extraction, processing, manufacture and delivery of the building materials to the building site. Obviously, from this point of view, if you go for the consumption of the energy, definitely there will be release of the carbon dioxide. Okay, and definitely carbon dioxide is a very important gas in terms of the global warming. It is actually contributing to the fact that it is a greenhouse gas, and it is actually contributing to the increase in the temperature in our atmosphere. Okay, so it is actually an indicator of the overall environmental impact of the building materials and system. So higher the amount of the embodied energy, higher the chances will be there that it is actually producing CO2. Okay. Unlike the life cycle assessment, which evaluates all the impacts over the whole life of a material or element, embodied energy only considers the front-end aspect of the impact of a building material. It does not include the operation or disposal. And that means whenever the materials will be used or they are going to be disposed of, it won't be counted as the embodied energy. It is a very small amount of energy. Still, we need to have an account of it. We need to set some limits for this. Okay, so through the building codes, just like your in RCC design or in road construction, you people will be aware of the fact that there are some codes which are provided for the civil engineers. Okay, these codes are telling you what should be the limiting value for one particular material to prepare a slab or any construction at a specific amount of precautions after taking specific amount of precautions. Okay, say for example, you people are going to build a building. Okay, so in that case, you people will need to construct the foundation at the first place, then there will be columns, then beams, slabs, everything will be there. So prepare a column, what kind of reinforcement is required at a particular condition when the building is going to have this much amount of load or this much amount of storage will be there in the building, what should be the clear cover at that particular column, each and everything are provided in the code. In similar way, there is a code for embodied energy. Okay, which will give us the idea about which kind of structural materials we are going to use and what kind of carbon dioxide emission will be taking place. So not about the structural materials but also about the rehabilitating of the old buildings. Okay, so if you go for the rehabilitation, definitely the materials required will be lesser compared to a construction of a new building, but depending upon the condition. Okay, for both the energy consumption as for the labor conditions. Okay, the proportion of the embodied energy in building has increased to more than 40% of the energy consumption. Earlier it was 10% only. Now it is coming out as 40%. And if you can go into a broader scale, if people will be able to understand that it is having an huge is having a huge impact on the global scenario. According to the United Nations, obviously by 2050, a third global carbon emission will come from the construction. Okay, a third of means the one third or around 33% of the carbon dioxide emission will be taking place through the construction process. Okay, so as a result of it, we must think about the reduction of this particular amount of CO2 emission. Okay, what are the ways that should be, what are the measures should be taken, what are the different guidelines that to be provided to people so that we can reduce the amount of the embodied energy. Okay, so energy consumption during the manufacture can give an approximate indication of the environmental impact of the material. And for most building materials, the major environmental impacts occur during the initial processes. Okay, if people are aware of the fact that how the bricks are being prepared, okay, they are actually burnt. Okay, mostly the clay will be used and they will be burned. So from that burning process, CO2 emissions will be taking place. So that is the part they are mentioning here. It is the environmental impacts occur during the initial process. Now the total amount of embodied energy may account for 20% of the building's energy use, that is comparatively less than the 40% that we are having nowadays. Okay, so reducing embodied energy can significantly reduce the overall environmental impact of the building. Okay, this embodied energy must be considered over the serviceable life of a building. Okay, serviceable life means for the time for which it will be in service. Okay, it may not be the exactly coming from the design life, because after a few years a building may not provide you the service that you are actually intended for. People may go to some place, somewhere else where the building will no longer be in use. So as a result, it is saying that it is in serviceable life conditions, lifetime of a building. Okay, so embodied energy must be considered over the serviceable life of a building, and in many situations, a higher embodied energy building material or system may be justified because it reduces the operating energy requirements of the building. Okay, how? Let us see an example. A durable material with long serviceable life, say for example aluminium, may be appropriate for the material selection despite its higher embodied energy. Okay, so it states that with some materials are there, obviously the higher amount of embodied energy could be present, but at the same time that material could be durable as well as long serviceable. Okay, so when you are going to select such a material, you people may look for the aspect of the serviceability. Okay, because it is actually giving you lesser operating energy. As the energy efficiency of a building increases, reducing the energy consumption, the embodied energy of the building materials will also become increasingly important. Okay, so it says that as energy efficiency of a building increases, okay, the reduction in the energy consumption is actually occurring. How? we have already studied this idea in the green building concept. When you people are constructing a building in such a way that it will be able to use the maximum amount of natural energy, okay, in that case the energy consumption will be lesser. When you people will visit some office, you people may be aware of the fact that at the point of at the daytime actually there are some buildings where the artificial lights are still working, okay, but at the same time in some other office buildings during the daytime they are mostly using the sunlight to lighten that particular interior of the building. So that is one position where the the energy consumption is actually lesser, okay. So if you go for the lesser amount of energy consumption, you people may be having the efficiency in using the energy in that particular building, okay. So in those cases also the embodied energy is becoming very important. Now you people have understood that what is your embodied energy, but now there is a question how to measure it, okay. In most of the cases in our country, whenever we are going to measure something, it is measured in terms of the amount of rupees or amount of investment that has been done. Say for example, if you are asked that how much electricity do you consume, you in a month time, obviously you people will be telling that my electricity bill comes in say 2000 rupees. In this way you won't be telling that my building has consumed this units of energy or electricity. People are actually aware of the fact that what is your amount of investment done on that particular project rather than the exact use of that particular thing. So in case of the embodied energy, you must be aware of the fact that it should be expressed in a quantity that should be measured, okay. You have the idea about the basics of SI system. So from that particular concept, when you are going to measure the energy, it should be in terms of the megajoules per unit weight or per unit area, okay. Megajoule or gigajoule, whatever it may be, per unit weight. The unit of weight is obviously kg, or in unit area, obviously area in terms of the square meter, okay. But the process of calculating embodied energy is complex and involves numerous sources of data. So as a result of it, we are going for a easier solution where the calculation will be easier for you. Now another question comes, how to reduce the embodied energy, okay. Buildings should be designed and materials selected to balance embodied energy with factors such as climate, availability of the materials, and transport cost. Say for example, you people are going to construct a building in this particular area, okay. Now you would be going for the availability of the materials, okay. You must be concerned about the climatic factors, okay. But same thing may not be true if you are going to construct a building near a coal mine, okay, because in those cases the cost of transportation of the materials could be very less, but the conditions of the existing condition on that particular area will be slightly different, okay. So as a result of it, despite the fact that you are going to have the materials at a lesser cost, you may need to spend much more amount in constructing the foundation. Okay, so lightweight building materials often have lower embodied energy than heavier materials, but at the same time, lightweight construction may result in higher use of energy. So if you are going to use a normal brick in a building, okay, I'm not going into very deep analysis of this, just for example you try to understand this. You are going to have a construction where you will be using the bricks for, obviously, for the walls. Okay, now if you go for the bricks which are generally burnt clay bricks, okay, you may have lesser amount of cost, or the initial cost will be less, but compared to the fly ash bricks or hollow bricks, that particular building will require much more amount of time to release the heat, because in case of the normal bricks, the amount of heat that will be absorbed by that particular brick will be very higher compared to the hollow bricks. So as a result of it, the overall energy consumption of the building will be very high in case of the burnt clay bricks. Conversely, the buildings with high heating or cooling requirements must be there with the with different temperature ranges. The heavyweight construction with obviously high embedded energy, and the inclusion of high levels of insulation can offset the energy use required for the building. Okay, so for buildings with high heating or cooling requirements, but there is a large diurnal, that is the day or night temperature range, heavyweight construction, and the inclusion of high levels of insulation can offset the energy use required for the building. Okay. Now, on the basis of the analysis that have already been done, we must be selecting the building materials in the following, with keeping in mind the following factors: the durability of the materials, availability of the materials, workability of the materials. I hope that people who are from the lateral entry, that means coming from the diploma student, are aware of the fact about the workability term. That is the ability to work on that particular material with minimum energy use. Okay. So another part is very important, that is the use of recycled materials. Okay. In most of the countries nowadays, they are actually working very hard on it, so that the generation of the waste, sorry, the generated waste could be used very easily. That is the recycled materials. Okay. Then specifying the standard sizes of the materials. Obviously, we are having some codes for this particular study. Okay. Avoiding waste. Again, the point is coming back. And the selection of the materials that are manufactured using renewable energy sources. So again, another topic is very, very important that we have already discussed in our previous few classes, but again, I will be telling you in the next class if required. That is the carbon footprint. Okay. So the carbon footprint of new build construction and the renovation is estimated as the equivalent to more than 1 million cars of the country's roads. That is coming from this study conducted in the country of New Zealand. Okay. So obviously we need to understand about the carbon footprint. It is nothing but the amount of carbon that is being used by one organization or one particular building or anything. Okay. So in 2019, The consultancy group in obviously in New Zealand, I'm talking about one particular case study here where one report was prepared. Okay, it says that a standalone house with a floor area of 200 square meter has embodied carbon of approximately 63 tons of carbon dioxide equivalent over its 90 years of life. Okay, now it is actually coming from one particular case study. So you can easily understand that with this much of floor area or with any amount, I mean, any value of floor area, how much amount of the carbon dioxide is actually coming, or the, I mean, embodied carbon is there, that is obviously expressed in terms of the carbon dioxide equivalent is there. So as a result of it, whenever you are going for the construction, you must be aware about the carbon footprint or the carbon dioxide equivalent of that particular material, so that selection of the material could be done in that particular way. So in this particular sense, the identification, assessment and influencing the embodied impacts, the embodied energy and the embodied greenhouse gas emission obviously becomes an additional design task. So other than the design purpose, that is how much dead load, how much live load is coming, what are the different environmental conditions that we are facing, if it is in the in which seismic zone, or doing the wind analysis. These are the very basic things. Okay, there are some new things that they are obviously which we need to do. Okay, and that is the finding the embodied energy values of the each and every building material that are going to be used. Okay, so it is often feared that if people are actually doing analysis, so we need to take some precautions also. So it is actually feared that a complete life cycle assessment has to be performed by the designer, and thus an extensive and highly elaborate research for data compilation and analysis must be carried out by the design teams themselves. Okay, so this is a huge task. Obviously, people who are from the civil engineering background are not only doing the design parts only, but they are also involved in doing this kind of analysis nowadays. Other than that, people who are actually from this particular science background are actually involved in this particular study. Okay, so they are also getting the importance, and as a result of it, the quantification of the embodied impacts are being taken into account. So for design professionals and consultants, it becomes increasingly important to deal with these embodied energy impacts. Okay, they need to quantify them, they need to evaluate them, then they will need to find the solutions and take the decisions accordingly, as well as they will need some time to make people aware of the particular study. Okay, so in regions with prolonged cooling or heating, like say for example, in India there is a place, Rajasthan. Okay, so during the month of summer, it is having very high temperature compared to the other parts of the country. There are some parts in near to the Ladakh where it is very cold during the winter. So it is, these are the regions with prolonged cooling and heating. Okay, the efforts in the recent year, they have led to some significant reduction of the operational energy consumption and greenhouse gas emissions after doing this kind of analysis on the embodied energy. Okay, then in regions without a heating or cooling periods as well as engineering structures, the energy consumption for these stages of manufacture and maintenance will prevail. Okay, there are some countries, in selected countries, the task of reducing embodied impacts has already been identified as a goal in the national strategies for sustainable development. Okay, so there are some country and there are some organizations who are working tirelessly for this particular thing. Okay, they are having their own methodology and they are looking to implement it. They are looking to make people aware of the fact that what kind of problems we are going to face if we do not follow these particular rules. Okay, so it is their goal to provide some strategies to the people, and in selected countries and organizations the goal of reducing embodied energy has become the part of the task and requirement for the certification and purchase of a building. Okay, so these are the factors which are leading us to the fact that we need to understand about the green building concept. Okay, there are some areas where the sustainability assessment has been done. Qualitative to quantitative methods are present, obviously. In addition to them, the life cycle assessment and are also very much important, and these things are being targeted with the use of different kind of resources. Then there are some real estate industries are there who are actually focused on the aspect of carbon footprint. Okay, this is obviously an important approach for describing, evaluating, and influencing the greenhouse gas emissions in the life cycle. Okay, and lastly, the demand for the net zero energy and the net zero emission buildings are actually growing. Okay, obviously, it is practically not possible yet to find the perfect kind of building with net zero energy, but we are actually going for this kind of using this kind of technology, which will enable us to reach this particular goal. So, for the design professional consultants, they are actually facing these kind of challenges. They are dealing with them on a regular basis. This is a very important task for all of them. So they need to do some they need to have some strategies and they need to do some works on it so that it will enhance the chances enhances the image and competitiveness of the designers for the designer firms, and demonstrates the personal commitments and acceptance responsibility for the environment and the society. So whenever people are actually doing this kind of work, it is not only for just for their own personal goals, but also they are actually doing I mean they are actually giving something back to the environment from where they are actually taking the different kind of sources of energy. However, the embodied impacts should not be analyzed independently. Okay, there are some partial aspects of a complex debate on this particular issue. On the overall performance and the sustainability of construction works, the consideration of full life cycle, there is a life cycle analysis and complete calculation of resources must be there. The environmental impacts must be there. Okay, so after doing this kind of complex, dealing with this kind of complex issues, obviously we will need to understand that all these particular things are actually related to the environmental impacts. Okay, so this is another part, obviously, role of design professionals and consultants. I'll be sending this particular note with along with the previous one also. So in the previous few classes, we were talking about the environment and energy. Okay, there are actually three E's. One is economy, then energy, and then the environment. Okay, so all these things are actually related one. So embodied energy is definitely one of those three E's that is coming to the energy, obviously, which will not only affect the environment but also affect the economy of that particular area. Okay, so with this, this particular discussion is over for now. Now, students, if you have anything to ask or anything to say, please go ahead. Most of you are from from the lateral entry backgrounds and are relatively new to this particular subject. But at the same time, I will be asking you if you have any kind of doubt regarding this particular topic that I have told you today, then please make sure that I will be clearing all your doubts before the class ends. I hope that most of you understand Bengali, so I'll just ask one last time. কারোর মনে কোনো প্রশ্ন থাকলে জিজ্ঞেস করতে পারো, কোনো প্রবলেম নেই।
নো স্যার।
না স্যার ঠিক আছে।
ঠিক আছে স্যার।
Okay, one more thing that I would like to mention. In the morning, there was an webinar. Actually, few of you joined there.
ইয়েস স্যার,
কয়েকজন
আই
তোমাদের
জয়েন।
মধ্যে ছিলে।
ইয়েস
So
স্যার আমিও ছিলাম।
I will be sending you a feedback form regarding that, and obviously you people need to submit that so that you people will be able to prepare the certificates for all of you.
স্যার আমিও
But
ছিলাম, আমাকেও পাঠাবেন।
okay, actually, I will be sending that feedback form to all the registered participants as well as the participants from the other list. But I may not be able to get the exact email ID of all the participants. Okay, but those who have registered, I will be sending that particular mail
ইয়েস
to
স্যার,
them.
আই হ্যাভ রেজিস্টার্ড।
Okay, now the question is, what you have tried to learn from that particular thing? Obviously, it was the technology that is being used by the different engineers, and obviously research works are still going on in that particular topic. But there is there are some applications from that particular technology which we can take into our civil engineering aspect. Okay,
স্যার,
so if
বিকজ
there
অফ
is,
ক্লাস আই কুড নট অ্যাটেন্ড ফুললি স্যার,
anyways,
অ্যাজ মাই
let me
ক্লাস
tell
ওয়াজ
you.
গোইং অন স্যার।
Okay, that is fine, but let me tell you, there are obviously few advantages of using that particular technology into the works. Okay, say for example, you people are actually aware of the fact that we are going for the we are doing the construction, okay, and the designing also. But have you heard about the different kind of new technologies that are being used just to not only to build the particular building but also to have the sustainability aspect? Okay, so in order to get that particular point on the sustainability aspect, you will need to have some idea about the basic sciences. Okay, so when that particular technology will be used, say for example in the industry of the concrete technology, we people are actually using different kind of materials along with the cement, coarse aggregate, fine aggregate, etc., so that the strength or the durability or any property of the concrete could be modified. Okay, so you people might be aware of the fact that about the word is bioconcrete. Okay, so there will be some inclusion of some amount of material into it, which are actually biological materials, which will enhance the properties or modify the properties in such a way that it will be able to react in such a way. In the morning session, we are actually having one particular example where one stimulate was actually used when the temperature is increasing in inside a cup of tea. Okay, actually the tea was being poured in that particular cup, and when that cup was actually getting filled, the color of that cup was changing because it was having that kind of technology which will be, I mean, susceptible to the temperature. Okay, so if we can use those kind of technologies into our industry, that is the civil engineering or the construction, then it could be very, very useful, and not only about the construction. Okay, but for any kind of uses, it will help us to achieve the sustainability. Okay, so obviously in this particular topic, in this particular subject, you people will be able to understand about the sustainability. You people will be understanding the facts about the green building. Then there is another important aspect, that is your uh, carbon footprint. Then a better version of the carbon footprint is your ecological footprint. So all these things are actually interrelated. Just as the second speaker, Dr. Nivamish, was telling you that
Yes.
we all of you have to work in a collaborative way. Okay, so that the things could be exchanged in such a way that we will be receiving, or we will be getting more from the sciences or more from the nature. Okay, so with this, I hope that you people will actually concentrate on the things which are actually there in your syllabus, but along with that, you should not be stopping your thoughts on that particular thing only. If you have anything in your mind, you people may still ask. Otherwise, your class for today is over, and definitely we will be going for a similar kind of discussion on tomorrow. किसी के मन में कुछ सवाल है, कुछ पूछना है?
No, sir.
Okay, so thank you everyone. We will be
Thank you, sir.
meeting again on tomorrow from 3 in the afternoon, where
Thank
I
you,
will
sir.
be talking about another topic which we have previously discussed in our class. But as you people are mostly new to this class, I will be making you aware of that particular topic again. So thank you.
Thank you, sir.
Thank you, sir.